Yeah, so again, thank you for the opportunity to present this. My hope today is, to sort of demystify AI a little bit. And so I like to take it, so Scott was sort of, I think of this as really in three layers. You have a high layer, which is sort of the business problem. Why do I need AI/ML to help me make better decisions, or to provide customer service, or to, to have lead gen, things like that, versus then you have the sort of the middle, where the sort of the tech stack that makes these things happen. And then at the very lower level, we have sort of the algorithms, like what is the sort of the intuition behind the algorithms that power this stack. And so my hope today is to sort of illustrate how in higher ed we had some problems, and what we did to sort of accommodate those problems as they changed over time. And so really this talk begins with my just a little bit of history. So before starting Ivy, I ran another ed tech company called Optimal Resume, and we sold into the career centers at universities. And basically from 2004 to 2014, we were getting a lot of requests from our customers saying that, hey, we need to do more virtual counseling. We need to do sort of more remote work because students aren't coming into the career center. And so we started to think about that problem, like how can we sort of start to, provide remote service. And so we came up with a concept of a product called Brim. And so Brim was essentially a three-piece platform. It had a live chat facility. It had a video collaboration, much like Slack does today. And it also had capabilities for synchronous document editing. And so we had sold this to about 10 or so schools, but we never got really any traction with Brim, despite the fact that we spent 18 months building this technology, and that venture failed. And as any good entrepreneur, you want to try to understand why the project failed, to kind of do some diagnostics to see, hey, what could I have done differently? What could I have learned from this experience? And how could I have done something different to make a positive change? And so what we did is, so we after we realized that we weren't getting much traction in sort of this product that was very much like Slack, but really geared towards higher ed, we went and met with our customers and we said, well, why is this, this messaging chat platform, video, collaboration platform, why isn't this working for you? And the answer from UNC Chapel Hill, which is my alma mater, was that basically students were asking the same types of questions over and over again. And so what that caused was a lot of frustration for the people in the career center who were handling the customer support requests. And then certainly, the students weren't having access to these counselors after hours. And so it was just not a viable product. And so basically, when we had that meeting with UNC Chapel Hill, the light went off in our head that maybe there's a different sort of set of needs. It's not just simply, hey, we need to provide remote customer service, but also we need to, I think I skipped a slide here too, sorry. We need to provide autonomous remote customer support. So essentially, we need to provide the same value of being able to do things remotely, but also have it be autonomous, where a chat robot can be the customer support representative. And so that was the epiphany that started our journey down Ivy. Now, as Scott mentioned earlier, it's not like, it is difficult to jump into the deep end of AI. The best models have millions of pieces of data and require some sophistication, but there are definitely ways that you can start to provide an AI solution, which may not use machine learning right out of the gate. And so what our first iteration of our product was, was essentially this chatbot, which would be a virtual assistant that would be online 24 hours a day, be embedded on a school's website so that a student who's visiting anytime, whether it's during business hours or on the nights and weekends, could interact with this bot and get their questions answered. And so what we did as a first naive approach was, and I'm sorry for these slides, I don't know why Google Slides keeps switching things around, is that we came up with this concept of dialogue flows. And it was basically a more efficient way to navigate a conversation. So what we can do is you could look at the most common things people would ask a career center, you know, how do I create a resume? I need to prepare for an interview. And based on those, you can start to see what are the most common topics that people are asking about. And so our chatbot in its early days looked something like this, where you had a series of buttons, and based on which button someone chose, it was almost like a choose your own adventure. They would say, hey, I want to get resume help. It would take them to either another set of buttons that would give them more options, or it might give them a resume help guide, resume samples, etc. And so this was obviously a very naive approach, but it was really our sort of minimum viable product in sort of the AI space. But the feedback that we got was very much meh, right? It wasn't very interesting. It wasn't very powerful, and really presented us with an opportunity to say, well, how do we actually enhance this, right? So rather than these simple point and click, how do we actually provide real value to the end user, and then coincidentally still solve the problem, the business problem that the school had when buying this solution? And so this created the third need, was we also needed to make this engaging. And so as part of the engagement strategy for our product, we started to think, well, what can we do to make this more exciting to use, right? Where, what features could we add? And so we came up with the idea that we would add videos, embedded images, and then start to put the bot on multiple channels. We also added some other features to sort of make it engaging, but the feedback for this, after we made these enhancements, was this was really just, I would call it meh plus. It was a little bit more exciting, it had a little bit more value, but it was still not exactly hitting the nail on the head. And so we were still sort of chasing the exact need that we wanted to fulfill, which was, we wanted to have an engaging, autonomous, remote self-service product. But the key thing that we were missing was intelligence. And I want to spend much of the talk from now on demystifying sort of how the intuition for AI works. And so with this, I'd like to, and I'm going to use Ivy as a use case. So one of the things you have to think about with AI is that there are, as Scott mentioned earlier, there's lots of different tools, there's lots of different algorithms, and it's incredibly important to use the right hammer for the right nail. And so I'm not a, and AI spends lots of different topics, from robotics to, playing games like chess, to things like chatbots. And my expertise is not in all categories of AI, but more in the chatbot space, which has to do with natural language processing. And so I wanted to take some time to explain the intuition behind how machine learning works in a chatbot AI framework in the context of these problems, so that you can start to understand that this is not black magic. It is accessible to all of us, and the intuition is relatively straightforward. It's just there's lots of lingo and words that make it seem not accessible. And so what I wanted to do was to take an utterance that someone might say, to our chatbot, something like, where is the library? And so the way that our system works is that we use something called a multi-label classification algorithm. And this is it's a subset of machine learning, which is called human supervised machine learning. There are other types like self-play, where Go, like the game Go, the computer just plays itself. But this is actually human supervision, where a team of people, the team at Ivy, actually label this information. As Scott was mentioning with some of his images, oftentimes they'll have teams that put bounding boxes around faces, and that's how facial recognition works. And the same principle applies to text analysis as well. But instead of putting a bounding box around my face, we actually label the data. And so with our labeling system, we essentially try to capture the gist of what someone is saying. So they may say, the question, where is the library? And our team of curation experts will label that question library and location, right? So it's got these two sort of characteristics that really represent the gist of what that person is asking, right? Now, if you look at this from another perspective, so the first one was about asking what is the location of the library. Now, this is the second question the bot get is, well, what are the hours of the library? So it's not about the location, it's about the hours. And so you can see that this received a different set of labels. It received library and it received hours. And so after you start to label lots and lots of data, I mean, millions of pieces of data, you can start to build logical tree structures. So for example, you can say that hours and the location are both related to Ivy, are both related to the library. And then you can see that this question, what are the hours of the library, is classified under that label set. And so after you have lots and lots of training data, the AI starts to learn what these things, when a person is looking for the library hours, they can say it in lots of different ways. And essentially, the AI algorithm predicts the labels associated with the words that the person is asking. Now, in terms of, this is really only one part of the equation. So the second part in my slide is not advancing here. I'm not sure why. Let me hit that again. So the second part of this is, okay, well, great. Now we understand that the training data is organized into a hierarchical structure like a taxonomy or an ontology. But the other question is, well, how do you actually get those answers into the bot's brain, right? And so with every one of those label sets, there will also be a corresponding answer. So when someone says, what are the hours of the library? And the AI predicts those label sets, we look to see what answer is also associated with those label sets. Now, in terms of how information gets into the bot's brain, the way that Ivy works, and this is not universal across all chatbots, is we actually crawl our customers' websites and we sort of link all of the content in their knowledge bases in their public-facing websites into things that someone might ask the chatbot. And so ours works with a web crawler, but in many cases, it's just simply adding answers associated with common questions that people might ask. Now, I want to spend some time on the intuition behind the math behind the AI. This is not going to be deep. I don't want anyone to worry about the sort of math, but my objective is to show you that this is not as complicated as you might think it is. And the math actually is very intuitive. My philosophy is that if you're going to embrace something, it's probably a good idea to understand it. And so I wanted to present you with sort of the intuition behind how these models work, at least from the semantic analysis, which is what Ivy focuses on. And so in this slide, what you see are, 6 questions, and then there's this sort of black line sort of separating them. And what you'll see also is that every one of the words that is used, so in this question, where is the library? You can see that there's a 1 next to the word where, there's a 1 next to the word is, there's a 1 next to the word the, and there's a 1 next to the word library, and all of the other ones are 0. And so essentially, we do that so it's basically a binary, it's either a 1 or a 0 related to the frequency of the words used in the sentence. And then these first ones are about library location, and these at the bottom are about the hours of the library. And so what will happen is when someone asks a question, is the library open? We look at the same set of ones and zeros associated with the new question, and we find the best match of the clusters of those predicted labels. And so the idea is, and I don't need to get into the matrix algebra or the vector math, it really doesn't matter, but the intuition is it's looking at a bag of words and then finding the closest constellation of questions that have similar label sets and then recommends those labels. So in this case, if someone says, actually, let me go so if in this question, is the library open? The bot generates the labels, or the AI generates library in hours, but we have to actually return the answer. And so we look down that tree, we find the answer, and then fire that into the chat. Now, there are really two types of AI, and so, or two types of chatbots, and one is called retrieval-based, and the other is called generative. In retrieval-based, it's basically a static answer, and the bot just returns that. But in terms of generative, the bot can actually generate real sentences using nouns, verbs, adjectives, and adverbs to actually build answers on the fly. Even the best state-of-the-art generative chatbots right now are not very good. Ivy is somewhere in the middle of between retrieval and generative, because if you take a look at this example, where it says, where is the library and what are the hours? You can see it's commingling two different ideas about where the library is and what the hours are. And so in this case, what the AI would do is it would predict three labels. It would predict library, it would predict hours, and location. And because it makes those three predictions, well, we have two answers that are relevant to what that person asked. And so from there, what we're able to do is we're able to create a compound answer where we say the library is open Monday through Friday, 6 a.m. through 12 a.m. and is located at 123 University Drive. And so these types of compound answers are a very interesting way to respond when there are multiple labels that cross different trees. Another thing to sort of just be aware about in AI is when someone asks a new question, when they say something like, what is inside the library? That's never been asked before. And so the AI may only generate one label, library. And so the bot may not have an answer for just library. And so the bot will respond, hey, I only know a little bit about the library. Would you like to know the hours or location? And so basically, how the bot and AI gets smarter is if that question is now added to this sort of spreadsheet view, you can see it doesn't fall in, it has a different semantic meaning than these other two categories, and we would do the exact same thing. Our team would create a label set, which is like inside and library, and then we would map these, these words out into that matrix, and basically the AI at this point will now have another node on the tree that has one piece of training data, which is that new question that was asked. And then we, of course, have to add another question along with it as well. Now, the last and sort of final need is this concept of personalization. So what typically happens is, as people start to use the chatbot, they start to ask it personal questions like, what is my account balance? Why do I have a hold on my account? And so we needed to start to accommodate this need for personalization in the chatbot. And so in this example where this young lady is asking, why do I have a hold on my account? The AI works a little bit differently in terms of rather than having just a static answer, we're going to need to get the information from another system. And so in this case, where this person asked, why do I have a hold? Again, we have labeled content like account, hold, and reason. And And when we look on that tree, what we'll do is when that label set is triggered, we'll say, hey, stop. Before we answer that question, we need to single sign on you into some system that is going to provide us with that information. And so when we generate the right label set, we basically say, before we can answer that, sign on, and we'll connect you to the student information system or the ERP or whatever is holding that information, and then return it with an API endpoint and say your hold is because of maybe you didn't pay your library book fee or something like that. Now, the future of chatbots, one of the things that's going to be very useful going forward is this concept of multi-turn conversations. Right now, in the world of chatbots, it's usually just a simple question and answer. But what you want to be able to do is if someone says, what is the application deadline? And the bot responds with the application deadline is Wednesday, the person should ask, well, where can I find it? And we know that they are talking about the application, even though I didn't use those words application in where can I find it. And so this concept of multi-turn is facilitated when you have these multi-label classifications. Now, in conclusion, I wanted to kind of pull back to the business issue at hand. Was at the end of the day, this actually works extraordinarily well. And so when we look across all of Ivy customers, we've seen a 60% reduction in call volume to the call centers. So whether it's in the bursar's office or the IT help desk, we're seeing lots of reduction in call volume. On the sort of marketing and communication, sort of the admissions area of the school, we've seen a dramatic increase in applications because students are engaging, they are finding the information they need, and that obviously is an important metric as schools are trying to drive their enrollments. And then we've also seen a very significant decline in the reduction of emails. And so my point in all of this discussion today was to show you that, hey, this is not a mystery. It's totally understandable intuitively. Yes, you may not need to be, a math major or a PhD to understand this. And at the end of the day, this actually does deliver excellent results to our partners. And so I would encourage you to, as you start to pursue AI ML solutions for your businesses, to obviously investigate things internally, partner with companies, and really embrace this, as this truly will be the future of how customer service, internal and external, will be performed pretty much forever going forward. So Courtney, thank you so much for allowing me to present. And with that, I'll pass it back to you.
Awesome. Thank you so much, Mark. That was great. And I think this is, I think it's awesome because now universities and their staff can really focus on what matters most in serving the student and kind of refocus their priorities. And with that, one question I have is, are you finding that there's kind of a barrier or blocker of people adopting this technology or universities adopting this technology, or are they open to it and looking to innovate?
Yeah, there is a lot of momentum and demand in higher ed for this type of technology. COVID in particular is really creating a lot of distress for schools. Schools make their money because students not only pay tuition, but they also pay for dorms and meal plans and sporting events and all of these other ancillary services that a school performs. And basically, we want to get students back to school as quickly as possible. And so if schools are considering a major hit to their revenue, they're looking for cost-saving solutions that allow them to scale better and to provide these remote services, whether their students are on campus or if they're off campus.
Awesome. And are there ways that you're continuing to think about how to keep that personal human connection with students? Because I know that is something that we run into with some of our customers and businesses we talk to, is even if I'm still going to be using AI, ML, how can I keep that human connection and keep that personal feel, even though it is a technology?
Yeah, so it's interesting. A couple of observations about that. The first is that oftentimes students actually feel like they're talking to a person, which is it's
Mm.
surprising, but you definitely you can read the transcripts and infer that they think they're talking to a human. So I do think it does deliver in part some of that personalization. Now, that being said, we also provide a mechanism to roll to a live agent when things really do require personalization. So, for example, if someone has an extraordinarily complex problem, or they have, maybe a mental health problem, you're probably not going through a chatbot is the smartest. And so we wanted to provide, a dovetail solution where it's, hey, let's triage a lot of the inbound sort of requests for low-hanging fruit questions, and anything that requires expertise, psychology background, we will provide a live chat tool so that that level of support could also be provided by humans to deliver that personalized experience.
That's awesome. Well, this is definitely such an exciting time for you and your business,
Yeah,
and being able to expand your reach and help these universities. So that's awesome.
awesome. Well, thank you.
Thank you. Thank you so much.